This question is from 2017 AP Physics 1 FRQ questions, and the College Board took out waves out of AP Physics 1, and now waves are in AP Physics 2 only covered. So I think this question might be appearing or similar in AP Physics 2. So it's still good to look at how this question could be responded. So they said that two wave pulses are traveling in opposite directions on a string. The shape of the string at t sub 0 is shown above. Each pulse is moving with a speed of 1 unit per second in the direction indicated. Between time t0 and t5 seconds, the entire left-hand pulse approaches and moves beyond point P on the string. On the coordinate axis below, plot a velocity of the piece of the string located at point P as the function of time between t equals 0 and t equals to 5 seconds. Let's assume that when point P is moving up, it moves in the positive direction, and when point P is moving down, it's moving in the negative direction. So in 1 second, because the velocity is 1 unit per second, in 1 second, the left wave is going to be in this position. So in 1 second, point P is at 0. Then in another second, I have the wave to be in this position. And the point P is going to be at this position. So the point P is going to move 1 centimeter up in 1 second. So it went from 0 meters per second to 1 meter per second by 2 seconds. So it just jumped to 1 meter per second in 1 second. And then for the next graph, wave of 1 second, we have the wave to be in this position. So the point is going to jump another 1 centimeter up. So for 2 seconds, the point moved 1 centimeter per second. So the velocity of the point is 1 centimeter per second positive. And before that, it was 0. Now, if I continue this graph, and at the next moment, I will have the wave to be in this position. And all of a sudden, my point is going to jump from 2 centimeters away to 0. So it changed the direction. It has a negative 2 centimeters, moved negative 2 centimeters in 1 second. So the graph is going to be negative 2 centimeters per second. And then after that, after the wave passes that point, the point is not going to be moving anymore. So the velocity is going to be 0. For the next part of this question, they ask you that at point t equals 5 seconds, the pulses completely overlap. On the grid provided below, sketch the shape of the entire string at t equals to 5 seconds. So let's do it at first right here when we have the problem, and then we will redraw it on the other one. So at first I see this wave, and it moves 1 unit per second. So 1, 2, 3, 4, 5. So in 5 seconds, this wave is going to be, or pulse, is going to be right here. For the next one, I have this pulse. And in 5 seconds, this part is going to move 5 units to the left. 1, 2, 3, 4, 5. So at this moment, I will have this pulse in this position. To draw the resultant shape of the string, you have to add both of them, because when the waves overlap, they either multiply themselves or make it larger, superposition of them, or they cancel each other. So what I see here is this graph, or this pulse and this pulse, they have exactly the same slope but in opposite direction. So the waves right here will be cancelled. So I'm going to have a 0 at this point. So the whole pulse would look like the black graph. So the resultant pulse at that point is going to be cancelled. Then I have positive 1 at this moment, and I have a negative 4 at this moment. So the resultant is going to be negative 3. So a positive 1 plus a negative 4 will give me negative 3. So that means I'm going to have the pulse coming this way. And at the next moment right here, they're both equal to 0. So 0 plus 0 cancels. So I have the pulse over here. And the way they ask you the question is to not draw the work, but only draw the resultant pulse. So for my graph, I have to not draw the work, but only draw the resultant pulse, the one that I did in black. So my resultant pulse is going to be equal to this, passing through the point P, then going 3 points down this way, and then 3 points up, and continue going. And after the pulses pass each other, they will continue going in the directions they were going. So the green pulse, after they pass each other, will continue going in its own direction, in this direction. And the blue pulse will continue going in this direction. So when you have two pulses coming toward each other, like in this picture, the left pulse is taller and the right pulse is shorter. When they overlap, in this case, it would be the superposition. If they were out of phase, if one of the waves or pulses was out of phase, then they would be either cancel each other if their amplitudes were the same, or they would cancel partially each other. So in this case, when they overlap, you see the superposition when the amplitude of both waves is added. And the direction of the waves does not change. They continue going in the same direction. So the taller one was moving to the right and still keeps moving to the right after the superposition. And the shorter one on the right was moving to the left. And it continues moving to the left as well after the superposition. And that is all I have for you for this question from 2017 AP Physics 1. The question that might be now covered in AP Physics 2 since they moved the waves into AP Physics 2. I hope you learned something from this question and it was useful and helpful. And thank you for watching, and I hope I see you in my future videos.